Hello, welcome to Tech Dicted. Today we will be looking at Crammer's rule. Basically, Crammer's rule is used to apply where you have the n equations. Okay, let me just use n equations and n unknowns. Basically, this means the number of equations equal to the number of unknowns. So in this case, we have I1, I2, and I3, and we have also equation 1, equation 2, and equation 3. Okay, yeah, so that's Crammer's rule. So in this case, it's applicable. That's why we're going to use it to solve for I1, I2, and I3. Question: I apply Crammer's rule to obtain I1, I2, and I3 given the following equations. And also something to note, you need knowledge on 3x3 matrices for you to apply Crammer's rule in this particular question, because in the case that you're given maybe 6i1 minus 4i2 and another equation 5i2 minus 3i1, okay, 22, and you want to apply Crammer's rule here, then it will be 2x2 matrices that will be applied. We will be using matrices a lot, and I hope that you have prior knowledge. If you don't, you can look at what we had before this, where we learned about finding determinants, which is very important right now. Determinants of 3x3 matrices. Yeah. So let's get started. First, we have to write this in matrix form. So this will be 6, okay, then -4, and then there's no I3, so this will be 0. Then I1 is -4 here, 11, -6, -6, +10. Oh, sorry, so this is 0. There's no value here. There's no I1, so this will be 0. Very silly mistakes. -6, and lastly 10. Always remember, when you're multiplying, this will be I1, I2, I3. Remember, your matrix multiplication, it's this way, okay? So this by this, this by this, this by this should be equal to this, okay? This by this, this by this, this by this, equal to the second one, okay? And then this will be equal to, now we've said this, the answer is the first one. This by this, the answer will be this second one. And then lastly, -20. Okay, so this is the representation of this, okay, in matrix form. Now, we need to apply Crammer's rule. Crammer's rule applies mostly determinants of matrices. So in the first, so we'll find first of all the matrix of this equation. Okay, just an explanation before we begin. Then we find the matrix of X, matrix of Y, matrix Z. Okay, so when we talk of matrix X, you replace these values, with this. Sorry, I kept saying matrix, but I mean determinants, okay? Determinants. So when you replace Y, you replace this second one with this, and Z, you replace this last one with these values. Yeah. So we start with the first one. Again, I will repeat. I hope you have knowledge because I'm really going to fly here. So it's 6 into, multiply this 2. Okay, we're closing this. So it's 110. 6 times 6, 36, but it's negative. So it's positive because both are negative, so they cancel each other out. So it's minus 36 minus, this is -4 into, cover this and cover this. So we have 40, -40, This is 0 minus 0. Okay, anything 0 into any bracket is always 0, so we don't even have to write it. Then we find our solution. This will be 6 into 110 minus 36 minus is positive, so this is plus 4 into negative 40 to 84. Okay, then we proceed to the next one. X. So when we talk of this, we mean replace this here. So we will have, first of all, let's just rewrite it. 10, 0, negative 20, negative 4. The rest remain the same. Negative 6, 0, negative 6, 10. Okay, so the rest remain the same. Then we have 10 into 110 minus 36 minus 4 into, so when we close this and close this, we have 0 minus, we've closed this, 6 times 20, 120. Now is it 6 or, yeah, so negative, so it's positive 120 plus, if it's 0 it will always be 0. Okay, so then we find 10 into 110 minus 36 minus, which is positive 4 into negative 120, you have 260. So this is 260. And then on our last one, let me just fold this so that it's okay. On our last one, we have, not on our last one actually, then we have the first values are, okay, negative, no, this is positive 6, negative 4, 0. Then we replace, this will come to the mid part, 0, negative 20, and then this will remain the same, 0, negative 6, 10. Okay, so we continue. So then 6 into 0, so into positive, so it's minus positive 120, okay, because it's 0 minus negative positive, so 0 minus 120, so it's positive, but it's generally negative. Okay, so negative 120, and then we come to the middle part, minus 10 into, close this, negative 40, this is 0, so automatically this will be 0, plus 0. So we have our final answer as 6 times negative 120 minus 10 into negative 40, negative 320. And lastly, we get another sheet. Okay, now we go to our last one. So this was the equation 3. We replace on the third column, 6, negative 4, 0, negative 4, 11, negative 6, 10, 0, negative 20. Okay, so this will give us 6 into 1, 11 into -20 minus 4 into -4, -20 minus 0 plus 10 into 0 minus, so this is minus, so positive 4. Okay, minus 4, since it will mess with what we're doing, minus 20, and then that's it, close it. Okay, so then we can now get it done. 11 times -20, 6 into -220 plus 4 into 4 times 20, since it's negative, so they cancel out, into 80, then plus 10 into minus, so minus cancel out, so negative. Okay, since it's this last one, so you've closed this, this is 24, so this is actually not 20, this is 6. Okay, then this is 0, so we have 24. So it's 24 minus, okay, when you close this and close this, sorry for that, we have primary minus secondary, so 24 minus 0, so this will be 24. Then now it's equal to 6 into -220 plus 4 into 80 plus 10 into, sorry, don't know why I'm messing up so much, 24. So we have -760. Okay, and so once we have this, we can easily progress and find our answer. So now we have the third, and we also have the first. Okay, so we have our determinant as 284, and then, okay, it's not visible, but we have our determinant as 284, and the other two as 260 and 260. This is x, then y we have -320, and then this last one -760. Okay, so once we have this, we now can easily say this was representing, this is when we replaced it on I1, this is when we replaced it on I2 and I3. Okay, so formula. Okay, so this is x, this will give us I1, I2, we have y, I3, z. Okay, so easily I1 is equal to 260 over 284. I2 is equal to -320 over 284. and I3 is equal to negative 760 over 284. Okay, calculator back. 260 divided by 284. I1 is equal to 0.9154 or 55. Negative 320 divided by 284. I2 is negative 1.1268. I3 negative 760 divided by 284, negative 2.6761. So this is A or amperes. Okay, yeah, so these are our answers, and yeah, this is it. Okay, so Crammer's rule can be used to obtain solutions to equations with same number of equations as unknowns. Thank you for watching. Let me see you in the next tutorial. Goodbye.